Question 16 from 2022 National 5 Physics Examination from the SQA, taken from Section 1. Heat from the sun melts 1.6 kilograms of ice in 40 minutes. The minimum heat energy required to change 1.6 kilograms of ice at 0 degrees Celsius into water at 0 degrees Celsius is, you're giving you 5 responses. Remember what's happening in this particular case. You are changing phase. The temperature is not going to rise, so it's not going to be the Cm delta T equation you're going to use. You're going to use the E equals ml equation. The energy supplied for the change of phase equals the mass, which has been changing, and multiplied by L. And you've got a choice here. L can either be the specific latent heat of fusion or the specific latent heat of vaporization, and it's up to you to which one to choose, and you're given two tables there. Now the clue is you are melting ice, so when you're melting ice you've got to use the specific latent heat of fusion of the material. So we look up our table and we try to find out the specific latent heat of fusion of water, and you can see it's that one there, ringed, 3.34 times 10 to the power 5 joules per kilogram. That's how much joules it needs to melt solid water, ice, into liquid water at the same temperature. So now we know the L value going to be used. All we have to do is just simply put it into the equation. Energy supplied E is equal to M, and that's going to be 1.6 kilograms. That's how much we are melting. And we have to multiply that by the specific latent heat of fusion of water, which we just found out from that table is 3.34, and multiplied by 10 to the power 5. And the units are going to be joules per kilogram. And you can see the 2 kilograms cancel out. You're left with joules. So we do that in our calculator. We end up with the following answer. We end up with 534, and we're going to end up with 300 in joules. But if you look carefully, it's not going to give you that answer. It's going to give you the answer in standard form. So we have to change this into standard form. So E is equal to, start here, 1, 2, 3, 4, 5. So it's going to be 5.34 times 10 to the power 5 joules. And we want to keep it to two significant figures. We can always round down, because it's a 4 here, to our final answer of 5.3 times 10 to the power 5 joules. And that'll be our final answer. And that's going to be answer over here, D. 5.3 times 10 to the power 5 joules. Answer D. Question 17. A cyclist is riding a bicycle along a level road. The combined mass of the cyclist and the bicycle is 70 kilograms. The total contact area between the tyres and the road is 8 times 10 to the power minus 4 metres squared. And we asked to find the average pressure exerted by the tyres on the road, and our answer is going to be in pascals. Well, we start off with our equation sheet. We know that the pressure P is always equal to the force over a particular area, and that's the contact area. Now the force in this case is going to be equal to the weight of the person, so we have to work out the weight, the combined weight of the bicycle and the person, and we do that by using the equation weight equals mg. So we only have 70 times 9.8, and that's going to give us the weight of the actual bicycle and the person, which is 686 newtons if you do it in your calculator. So now we've got the actual force, which is the weight pressing down. We can go ahead and work out the pressure. The pressure is going to be equal to the force, 686 newtons, divided by the area, and the area is going to be of contact 8.0 times 10 to the minus 4. And that's going to give us an answer of, remember that's meters squared, that's going to give us an answer of 857 in our calculator, 857,500. And the units are going to be Newton per metre squared, which is going to be the Pascal. Now 857,500 is not appearing in that particular list of answers there, which means the answer must be in standard form. So if we have 857,500, we put that into standard form, that's equal to 1, 2, 3, 4, 5. That's equal to 8.575 times 10 to the power 5 pascals. Now we keep it to as best we can to our two significant figures. So 5 here, a 7 there, rounds us up to the 6. So 8.6 times 10 to the power 5 pascals. Remember for the units here that 1 pascal is equal to 1 Newton per metre squared. So the answer we're looking for is going to be 8.6 times 10 to the power 5 pascals, and that's going to be answer E, 8.6 times 10 to the power 5 pascals. Question 18. The average kinetic energy of a gas molecule can be determined using the following relationship. EK equals 3/2 K subscript B times T. And we're told what these things are. You've not seen this equation before in a National 5, but don't worry, you've got all the knowledge to do this equation. So EK is the average kinetic energy of a gas molecule in joules, J, and K subscript B is a constant called the Boltzmann constant, and that's usually a number equal to 1.38 times 10 to minus 23 joules per Kelvin. T is the temperature of the gas molecule in Kelvin K. That's the only thing we have to remember here. Now the average kinetic energy of a gas molecule at 100 degrees Celsius is, and we're given our 5 responses. First things first, change that temperature into Kelvin. So we know that 100 degrees Celsius. If we want to change it into Kelvin, we just simply add on 273. That's a little number machine to do that. And we end up with 373 Kelvin, and that's our answer for that. So we've now got our temperature. Now let's plug in our numbers into the equation. So we have the following. We'll get EK, I'll do it down here for you. EK is going to equal to 3/2, which we'll write as 1.5, multiplied by Boltzmann's constant KB, which is this number here. So 1.38 times 10 to the minus 23. And finally, we have to multiply that by our temperature in Kelvin, which we worked out to be 373, so 373. So we'll do that in our calculators, and you end up with a value of 7.72 times 10 to the minus 21, and the answer is going to be in joules. So we look up our data, our responses here. It's the last one here, 7.72 times 10 to minus 21 joules, and that's answer E.